Welcome to my channel, dear students and all the viewer. See, this is the chapter for the inverse trigo, and it is important for the 10+2 level. And this problem was given to the exam advanced 2019. This is known as IIT in India. So this is the inverse trigo problem, and it is given that the problem is here for a non-zero integer n. Non-zero integers n, let f of n is equal to summation k 0 to n and sine of k plus 1 divided by n plus 2 times of pi, and sine of k plus 2 divided by n plus 1 times of pi, and over this is summation k equal to 0 to n and sine square k plus 1 over n plus 2 times of pi. And it is assuming that the cos inverse x, the values of x is takes from 0 to pi, and in the closed interval, and following option which is or are correct, that is option is given that first is there n tends to infinity, f of n is equal to half and f of 4 is equal to root 3 by 2, and if alpha is equal to tan of cos inverse f of 6, and then alpha square plus 2 alpha minus 1 equal to 0. And also it is given that the number of last option, that is D, and sine of 7 times of cos inverse f of 5, that is equal to 0. Now first we want to simplify this figure, which is very important point for this problem. This is f of n, function of n, and this is summation from k equal to f of n, and this is summation k equal to 0 to n, and that is sine k plus 1 by n plus 2 times of pi into sine k plus 2 over n plus 1 times of pi, and this is over, and summation from k equal to 0 to and this is n, not infinity, I am wrongly written here, this is n, and this is sine square and k plus 1 over n plus 2 times of pi. Now multiply it by 2 and 2, then we got the expression, this is k equal to 0 to n. If we apply the product pattern of sine, and there is two sine of alpha and sine of beta, so it could be written as like and cos of this minus this, so we got here pi by n plus 2, okay, and now cos of this plus this is 2k plus 1 plus 2 is 3 here by n plus 2 divided by n plus 2 times of pi, and this is okay. And now see, here is a 2 times of sine square like theta, so it can be written as with the help of multiple angle, that would be here 1 minus cos 2 theta. So summation of n times 0 to n times of that, no, right here 1 k equal to 0 to n, this is 1 minus and cos, this is 2 times of that 2k plus 2 over n plus 2 times of pi. Now say this is here 0 to n, so number of term here is n plus 1, so this is as a constant, so n times of n plus 1 times of cos of this is pi by n plus 2, and minus, and summation from this, if we put 0, we got here cos 3 pi by n plus 2 plus cos, if we put here 1, we got here 5 times of pi over n plus 2 plus dot dot, and cos of this is, if we put n, so it would be here 2n plus 3 over n plus 2, okay, and this is here, so 1 times of that, so this is n plus 1 times of 1, and now summation from 0 to n, so put the value 0, so this is 2 pi over n plus 2. If we put 1, then we got here 4 pi by n plus 2 and dot dot dot. If we put n, so we got here cos 2n plus 2 over n plus 2 times of pi. Okay, now I want to simplify this expression, these two. Actually, very easy technique. Let this is pi over n plus 2, same as pi over n plus 2. Let us assume this is as the alpha. Okay, so therefore the cos 3 alpha cos 5 alpha plus dot dot cos 2n plus 3. Okay, this is a pi. So and this is alpha. Okay, now write here 2 times of sine alpha, then 2 times of sine alpha and cos 3 alpha, that is a sine 4 alpha minus sine 2 alpha. For that, this is here 2 times of sine alpha into cos 5 alpha, that would be here sine 6 alpha minus sine and 4 alpha, and same as for this expression, that is a sine of this is here plus 1 plus alpha means plus 1, so 2n plus 4 times of alpha minus sine 2n plus 2 times of minus sine 2n plus 2 times of alpha. Okay, so therefore this is 1 over 2 sine alpha, so this is equal to, so these all are cancelled out, and this is the biggest figure and this is the smallest figure. This is 2n plus 4 times of alpha minus sine of 2 alpha. This is 1 over 2 into sine alpha into 2 into cos of this plus this plus this. Actually this is 2n plus 6 alpha over 2 into and sine of this minus this, so this is 2n plus 2 into alpha by 2. This is 1 over 2 into sine alpha, so it is written as 2 are cancelled out, so this is cos times of this is here n plus 3 into pi by n plus 2, and same as sine of n plus 1 into pi by n plus 2. So if we simplify, this is here sine of n, okay, alpha means pi over n plus 2, pi over n plus 2, and this is, if we simplify, and this is cos of pi plus 2, this is pi minus pi over n plus 2. Okay, no, plus. Okay, this is here plus 2 3. Okay, and same as sine of this is pi minus pi over n plus 2. So okay, and this is minus cos of pi over n plus 2 and sine of pi over n plus 2, and over and sine of pi over n plus 2. So these two are cancelled out. We got here minus cos pi by n plus 2. Okay, and now for this expression, and this is for this expression, this is cos 2 alpha cos 4 alpha dot dot cos 2n plus 2 into alpha 1 by 2 sine alpha. This is sine of 3 alpha, sine of 3 alpha minus sine of this minus this sine alpha. Okay, same as sine of 5 alpha minus sine of 3 alpha, and this is sine of 2n plus 3 into alpha minus and sine of this is n plus 1 into alpha. So we have left only 2 into sine alpha and this is smallest term, and this is the 2n plus 3 into alpha minus sine alpha, 1 over 2 into sine alpha, and this is 2 cos of 2n plus 3 plus 1, this is 4 over 2, and this is n plus 2 into alpha into sine of this minus this over 2, this is n plus 1 into alpha. This is 2 are cancelled out, 1 over sine alpha means pi over n plus 2, and this is cos of n plus 2 and pi over n plus 2, and this is sine of n plus 1 over n plus 2 into pi. So this is here cancel out, cos pi is here minus 1. So 1 over sine of pi by n plus 2, and this is actually pi minus pi by n plus 2. So this is here minus 1. Okay. So therefore our expression is here f of n, and that is here n plus 1 times of cos of pi over n plus 2 and minus, and we got here minus minus plus cos of pi times of n plus 2, and now see here this is n plus 1 minus, and the expression of this is here minus 1 we got here. Okay, so if we simplify, we got only cos pi over n plus 2. So the first option C, this is n tends to infinity for a, limit n tends to infinity f of n, and that is equal to limit n tends to infinity and cos of pi by n plus 2. We can write here pi over n and 1 plus 2 over n. So 1 by n tends to 0. So this is cos 0 by 1. Okay, cos 0 is here 1. So A is incorrect. So see, this is here given that half. So therefore the option A is incorrect. Now f of n is equal to, we got it here, this is cos pi over n plus 2. So therefore f of 4 cos pi over 6, and this is root 3 by 2. So option B is correct. Okay, now C option C, and now find first f of 6, and this is cos of pi over 8, cos pi over 8. Okay, and this is alpha is equal to tan of cos inverse, and this is cos pi over 8, and this is tan pi over 8. Now tan pi by 4 is equal to 1, implies that tan pi by 4, it can be written as tan pi by 8 to tan pi by 8 by 1 minus tan square pi by 8 is equal to 1. So this is here alpha. So you can, okay, so 2 alpha by 1 minus alpha square, that is equal to 1, and therefore we got here alpha square plus 2 alpha minus 1 equal to 0, and therefore the C option is correct. Okay, now for the last option, that is sine of 7 times of cos inverse f of 5. Now first find f of 5, and put here 5, then pi over 7. So cos of pi over 7. So 7 times of cos inverse cos pi over 7. So cos inverse cos are cancelled out. 7 times of pi by 7, 7 are cancelled out. So sine pi is 0. This is the correct option. Okay. Thank you for watching my video, everybody. Welcome to my channel, dear students and all the viewer. See, this is the chapter for the inverse trigo, and it is important for the 10+2 level, and this problem was given to the exam advanced 2019. This is known as IIT in India. So this is the inverse trigo problem, and it is given that the problem is here for a non-zero integer n,